InSpec webinar here. And as we're kicking off here, I realized I forgot to change March to May here on our slide. You always find at least one typo in these slideshows every month. So we've been doing these webinars. In 2020, we did a monthly. This year, we are going to be doing them bi-monthly. And I love it. There's been a lot of feedback from all you who have been viewing. So this webinar is actually all based on our customers, you guys, examples and things that you guys want to learn about, ideas that you guys sent me. So I hope everybody learns at least a little bit something today. One thing that I wanted to start off with was Windows 10 update public service announcement. I've had a bunch of customers that have been reaching out wanting to their IT department, or they are looking to update their computer to Windows 10. Our service team has put together a great, easy to follow work instructions to update your computer that's running InSpec to Windows 10. It's very easy to lose your calibration files if it's done wrong, so please contact us before updating to Windows 10, and I can send you a quick little PDF that explains what to do and how to do it. And this also applies if you need to get a new computer for your Micro-Vu, and just make sure we save those calibration files and everything. So I just wanted to send that out there to you guys to kick this off. Another thing I want to talk about is we have a new location in Warsaw, Indiana. I'm currently in Bartlett, Illinois, which is just a little west of Chicago. And we have Ryan, Dan, and Adam Churchill joining us today too. They're from ATI. They're actually down at the Warsaw office today. It's really cool. Contact Adam at atiquality.com if you're in the Warsaw area to hear more about it. But we are hosting a metrology training seminar down at our Warsaw location. We're going to be covering hand gauge training, blueprint reading, the Micro-Vu InSpec software, the basic and advanced class, and then a new Micro-Vu GD&T specific class. So there's discounts available for multi-day registrations. So you can contact us for more information on here. And here's a little flyer that I put together. July 12th, you can choose in between the AM and PM session for hand gauge training. This is perfect for new techs to the industry, or those just looking to get their skills solidified up in hand gauge usage. And then July 13th, we have a blueprint reading class. Same thing, you can choose AM or PM session, whichever one fits your schedule and shift the best. Just learn the basics of everything blueprint, all the lines, symbols, tolerance boxes, everything that you might come across. Again, great for new techs to the industry, new hires, or those just looking for a review. Even though you've been looking at blueprints like a lot of us for 10, 20 years, there's some things you either forget or you're not sure how to interpret. It's a great class for the fundamentals of blueprint. And then if you've ever been through our basic or advanced training, we're hosting that on July 14th. And then on July 15th, it's a Micro-Vu GD&T specific. So after learning all the basics in advance of the software and some of the things we're going to go over today, the GD&T class is just specifically on how do we measure cylindricity, how do we measure true position, how do we measure run out, all those good things. So feel free to go to atiquality.com/events, and you'll find that there that you can register for more information, or contact us directly and we can get you more information there. So enough of advertisements for you guys. Let's get into why you're here. I always do a webinar review of the last one we did. We talked about basic, intermediate, and advanced programming tips. We talked about measuring flash and burrs. We didn't get to touch on storing systems and features, so I'm going to go over that more today. We talked about chamfers, the difficulties of measuring chamfers, because you have to flip working planes. The last two webinars that we hosted, we talked a lot about flipping working planes because it's a very advanced feature that you really need to understand how setting systems up work before you even get into that. We're going to talk about running. Another thing we didn't get to talk about last month or in March was running multiple parts. And any new Gen 3 features on there. So I also had a bunch of requests to talk about fixturing. So I have a little section in this webinar today about some fixturing examples that we use here at ATI, and just a little tips and tricks for fixturing, because that could be half the battle of your inspection process. So the basic tip that we talked about in March was which way should we have the red arrows go when we're scanning. Go dark to light, light to dark, does it really matter? And a lot of you didn't even notice the red arrows if you've been using it for a long time or recently. The best tip that I have to give about which way the arrow should go is which side of your measurement has the less noise. And when I talk about noise, I mean the less gray values, because your camera is measuring in pixels. You've probably heard me say that a million times, and it's looking for the highest contrast between light and dark. And if there's a lot of gray value in there, like this little gasket we have, and that arrow scanning from the surface of the gasket to the outside, that would be your glass where the profile light's coming from, or surface light if you're using that, it could pick up any point in those gray values. So you might not get a great scan on that edge there. So I would click on that dashed line, move it over to the other side, and then have it scanning from light to dark on there. Now, if we were using profile light on this example and the gasket looked completely black, and then you had some scratches or dust on your glass, I would go from dark to light, because there's less noise on the dark scanning direction to the light there. It's not always the case, but look at every single feature, every single tool that you use to determine which way your arrow should go. And these will save when you save the program. So taking the time to adjust every single tool in your program is worth the time. And it's also good to, as you're inspecting parts with programs you already have written, go through them the next time you open up that program and see which way those arrows are going. Intermediate level tip that we talked about in March was planning your magnification changes. So if you're running a program and you're going from low mag to mid mag, back to low to high mag, and you're changing a ton of times, you can be adding a lot of time to your program. Each magnification change takes roughly 2.5 to 5 seconds. So if you look at your blueprint and you're like, all right, all these measurements are going to be high magnification, these will be low, take those measurements in order of the same magnification. Even if it's blueprint number 1, 7, 12, take those and then reorder them at the end of your program on there. So you could save a lot of time in your inspection process. And I know a lot of you are measuring multiple samples, cavities in the same thing. So if you have 8 parts that it takes, let's just say 10 minutes, and you're doing a bunch of different magnification, you could bring that down, close to 6 minutes on there. And then that over time is going to save you a lot of inspection time. And we talked about measuring cones as the advanced level tip and letting the machine do the work for you. So we use the rotate function, talk about today, and then we use the translate down in Z. A lot of people use the translate function to go across fixtures or measure multiple parts. This instance, we used translate to bring diameter or focus points down in Z. So we clicked one focus point, and then we use rotate and translate and let the machine do the work for you. If you missed the March webinar, after this webinar, you guys always get the follow-up email with a survey. You can request the previous webinars recordings then, and you can view that. So this month, we're going to talk a lot about, like I mentioned, input from you guys, suggestions on topics. So we're going to have basic, intermediate, and advanced programming tips. I'm going to talk a little bit about the difference between concentricity and position, GD&T callouts. We're going to talk a lot about features you're probably not using daily. There's a few functions that I'm going to show you that aren't mind-blowing, but sometimes those are the feature that you wish you knew about 5-10 years ago. I'm going to talk a lot about fixturing ideas for you guys. And then at the very end, we're starting to have new Generation 3 machines hitting shop floors. And there's a couple new features that I wanted to show you guys that have that. So for you that have the new Generation 3 machine, awesome, you'll get to learn about it. Those who have Generation 1 and 2, it's just a little preview that if you guys ever get a new generation machine, things you could look forward to. So beginner level tip. Usually I like to keep these just as something simple to keep in the back of your head. Knowing the camera window size. This can help you out if you know you're going to be able to measure a diameter or anything it might be with an F-scan circle that has to fit in the camera window, or if you need to do more inputs with F-scan arcs. If you look at the low magnification, I have a glass scale here, we can see 11 millimeters within that camera window at the lowest magnification on my camera. Now, I do want to put in there as an asterisk, there are two different zooms, cameras on zoom lenses on these machines. So this might not be for yours, and you could throw a glass scale on there and see what your lowest mag and your highest mag, but this is a general size of it, let's say. Medium mag, so I was about halfway down in my mechanical zooms and I only could see about 2 millimeters, and then when I was at my highest magnification, I barely could see 1 millimeter in the camera window. So just keep this in the back of your head when you're taking measurements, and this also applies to knowing your different zoom stops that I was talking about, planning your magnification. You know that how big of a feature you're going to be able to fit into every single one of them. And this also plays into when we get to features you might not be using every day, the auto generate drive points. And this will make sense to how many tools we can fit in one camera window at a certain magnification. Intermediate level tip I want to talk about today. It's a cool little trick. If you were here in the March webinar, we learned that we can't name features the same name when we rename them, but if we put a space at the end of the name, they can look like they're the same, but that space is considered a character. This kind of applies to that as well. Of if you're measuring circularity on one diameter, if you go to configure Summery Reports, I'll jump over there on my software. So if we come up to Tools, Configure Summery Reports, we can toggle on or off what we want to show in the summary window. So here, if I measured a circle, it's going to show me center X, Y, a bunch of other things, the polar mode if we're over in polar positioning, diameter, circumference, and circularity. But I don't want to see circumference and circularity on every single diameter that I measure because this is a global change. The one trick that you can do is just that one diameter that you want to show circularity is when you tolerance it, then it'll show up in the summary tab. So most of the time, if you're the programmer and you have multiple operators running the same machine, or if you have it on the shop floor and everybody on the shop floor is allowed to use the Micro-Vu, you want to have the least amount of information showing up in the summary tab, because you're more likely to write down a wrong number if there's tons of numbers going on over here. So I'm going to go ahead and go measure a diameter. So if I click circle, since I can see the whole diameter in my camera window, I can use the F-scan circle. And we can see here that it shows circumference and circularity on there. So if I go over to tools, go back to my configure summary reports, turn those off, I want diameter on there, and click OK. Now it doesn't show it. But I can come right click or hit F3 for tolerances. If I tolerance this guy, put it out of tolerance, then it shows up on there. So just a little trick that if you want less showing up on the summary tab, you can just tolerance it there. You don't need everything on there. I like having diameter on all the time because I don't want to have to tolerance it to show it, but little things to know. Another intermediate tip, so there's a little bonus one for you. Usually just do one each, but this didn't feel like a fully advanced tip. Rotating, using the rotate feature, best practices. One thing that I always get caught up on is when I go to rotate, I like going to 12 o'clock, but I also like using the F-scan arc tool to cover as much of that edge as I want. But that always gets me because when I rotate it 90 degrees 3 times, that tool is too large for the camera window because the camera window is wider than it is, I guess you could say, taller or longer here in the Y direction. So I've kind of got in the habit of starting at 9 o'clock or 6 o'clock or 3 o'clock, I mean, because then I know that that tool is going to fit in the camera window when I rotate it 90 degrees. Now, if you're rotating it every 60 degrees, with 5 copies, you're going to be fine no matter where you start. But if you just want to do 4 F-scan arcs, 90 degrees, start at 3 or 9 o'clock, and it'll help you out. So if we come over here, if we make this our origin, because we need a system to rotate about, and let's say I want to come into a higher magnification here. Get this guy back in focus. Bump up my lighting a little bit. I'll do circle, more inputs, F-scan arc. And then if I come down to my inputs and I right click, rotate, I'm rotating about system 2, which is the center of my circle. I'll do 3 copies because we have 1 already, and I'll rotate every 90 degrees. Then I can right click, remeasure, and that failed because there's bad contrast. You should spend time on your lighting. Last year I did a full hour on lighting tips and tricks, so that would help you out. But for time-wise here today, just doing general surface lighting on this guy. But you can see the tools fit in the window. But if I came to 12 o'clock, and my normal habit, just when I'm clicking around and not really thinking about my programming process, I want the tool to be as large as possible. So now when I rotate this guy 90 degrees, 3 copies, and I go to remeasure that circle, now the tool is too large for the camera window there. So then I have to move the camera up, bring the tool down, bring the camera down, move this tool, come back to the center, update it. So it's just wasted time when you're programming. So I'd rather just get in the habit of going to 9 or 3 o'clock around that diameter, hitting my arc and moving on from there. But if you're good at remembering how big of an arc you should have if you start at 12 o'clock, you can do that too. It's programming preference. And as I've said a lot in these webinars, I like just throwing all these information at you, these little tips and tricks to start a conversation. And I love hearing back from you guys of how you guys are programming, because as much as I train all you guys give us tips and tricks sometimes that we share throughout ATI, so everybody's becoming a better programmer. Let's talk about importing DXFs as an advanced level tip. Importing DXFs is really nice, generally when you have 2D parts, flat parts, because you're only allowed to select one lighting and zoom and focus setting when you import the DXF. But there are also tips and tricks that you can import the DXF, fully program your program to be able, or your sample here, to be able to tolerance, get all your distances, diameters, rename everything before it even hits the machine with physical parts. But then once you run the program, you can set lights and zoom to what you need. So basically, if I was going to measure this part here, this sample slide that everybody's probably seen a million times, I could get all the outside features at one light setting and one zoom setting. But if these diameters were posts, they wouldn't be able to be measured with profile light using from the outside and whatever the focus would be on these edges. But I could keep them in there, and then when I run the program, these posts are going to fail to measure because the light's not right. Then I can go ahead, change the lighting, update the tool, and run my program. Importing DXF files, they're really nice. This might be review for some of you that I believe my April or May 2020 webinar talked about offline programming. So you're able to get an offline seat of Micro-Vu Inspect to be able to program off of DXFs. So it's really good for if you're working from home, which a lot of us did in the past year. It looks like a lot are returning to the office lately. And then you could also program offline when physical parts aren't available. So if you guys haven't run that machine yet or run those parts yet, you can start programming, at least get halfway there, so it's less downtime of the machine physically measuring parts. Or if a fixture is being designed and built, you're able to at least start programming the part there. Increase productivity without machine downtime. So if your machine is running 24/7, 3 shifts a day, you can program on an offline computer and be able to not have to hog up the machine, the Micro-Vu, while programming a part. It's cost effective, so the offline version is a fraction of a physical machine. And then what I wanted to talk about today was the visual assistance. You can disable features after you've imported the DXF to be at least give an outline of your part. Because when we're measuring a brand new part and you don't know where certain things are, it's kind of hard to move around your part. But if you had an outline of your part all ready for you, it's easier to move around. And I'll show you what I mean by that. So there's 2 ways to do this. You can, if you have a DXF available, but it just came to mind that we also could use a spline tool. So I'm going to bump up my lights to avoid anything that's going on, that noise I was talking about. So before I input the DXF, I'll show you the spline. So if I do a spline tool, I'm going to make this fully automated. I'm going to do a spline, close spline. Now hopefully there's no scratches or anything on my glass, because the spline tool is just going to be following the contrast between light and dark. And if you have any scratches on your glass or any burrs or anything that it's showing black and white, it could start following that. So now I have an outline of my part, but I don't want every single time that I run this program to measure the spline, because if you put it, like I said, where there's a scratch on the glass, it's going to start following that scratch on the glass, and it could be running forever, and you literally have to shut down your machine to stop it from moving if it doesn't find its way back to that point, this guy right here, where we started it. So I can right click this closed spline, go to playback, and disabled. So now I have a nice just outline of my part that I won't ever have to measure again. And it's going to come in with my program every single time. So now I know, since I'm very familiar with the practice slide, I know if I right click, move here in the schematic window, there's going to be a diameter there. So it's easier to move around my part and be able to measure features quickly, because I'm not having to move it with the camera window or use the joystick, whichever one is your preference on there. So I'm going to go to File, New. I'm going to come to File. So importing a DXF, I always want to go to File, Open to open up a DXF file, but you got to go down to File, Import a DXF file. So here, you'll always open up a file wherever you keep your CAD files, or if engineering gave you a jump drive or wherever it might be. If you want to practice on the practice slide that you guys have, you all have the DXF in your Micro-Vu computer. And if you go to our advanced training manual, it shows you the file path. If you go to Program Files, you'll find Micro-Vu Corporation, Inspect for Windows. Sometimes it'll be in the samples folder, or it'll be all the way at the bottom of the Inspect for Windows folder. Some machines have MV sample or just sample. It's going to be the sample DXF. This one's a different shape. So I'm going to open that guy up. I know this one was designed in inches. Even if your blueprint says it's in standard, but if it was drawn in millimeters, you need to select how that CAD file was drawn on there. I have a customer, stamping industry, and everything's designed down at their plant in Mexico. They get their CAD files up in Milwaukee area, but their prints are in inches. So they always have to switch over to millimeters, even though they're looking at a standard print. If you've never imported a DXF before, and if you haven't had one of ATI's trainers, Dan or myself or Ryan or all the other trainers, we normally open this up when we're training you on DXFs and change it to the tools that we recommend using. A lot of the times it is standard that this will open up as splines, and when you open up a DXF in splines and it measures everything in splines, it's really hard to get information out of your measurements. So then you end up doing more work than you would have if you would have just measured your part. Also, I'm going to come down here. If you have a generation 1 or 2 machine, this defaults to 24. Generation 3 machines, I've been changing it to 100. And once I change it once, it should keep it it's a global change. So every time you import a DXF. And it's been a while since I've done this on this machine. I'm pretty sure it's 100. We'll see how the part reacts with the DXF on this. So I'm going to click OK. Now I got my DXF that's imported. I need to construct a system from imported features. So it's just like if you put the part on there and you were going to do line, intersection point, 2 diameters, whatever it might be. But we can, since all the features are imported, I can do intersection point of this line and this line. I can set my origin of X, Y, and Z to that point. And I can skew to this bottom edge here. And now I can click next because I have a system. I'm going to go ahead and remove the imported system. If you're doing a lot of profile measurements with DXFs, or you needed to compare it to anything, feel free to contact myself or Dan. We can work with you of best way to get your measurements that you need on your blueprint, and if you remove the imported system or not. I'm going to go ahead and just remove it for this. So this is where I was saying that you only get to choose one magnification and one lighting setting on here. So I picked profile light because it's a flat part. Again, if these were posts and I couldn't see these diameters, I would still pick whatever lighting I'm going to be able to get the most features with, and then later on I can adjust the lighting and the magnification for other 3D features. So now when I hit run, it's asking me to come down here, and it's got this black crosshair. It's saying use a best edge point here. So that earlier when I changed the 24 to 100, that's determining the tool size here. So you see that I changed it to 100 and I have a decent size best edge vision tool right here. If I would have kept the 24, it would have been really tiny, and then you're more likely to miss an edge. But like I said, if you have a Gen 1 or Gen 2 machine, the 24 is good for you. And now it's nice that once I start measuring a line off my DXF, it moves my programs over here. Even though it's saying the crosshairs are over here, I can right click in the schematic window because I generally know where my part is and move around. I'll come take that last point. One thing I want to hit, because I kind of skipped past it just because it's, just knowledge in my head. But if you import a DXF and you're not sure what tools are being used to measure that, you can see this black arrow says measure line 16, and it shows you what tools are needed on there. So you know if you're going to be able to have to click once, or if it's an F-scan line, you click twice. And now it just goes around and measures my part. And then boom, done. So now if these fail to measure, I can right click in the inputs list on that, say move here. I can adjust my lighting and my magnification, whatever it might be. I click the tool, I update it. So now when I save it as a Micro-Vu program, it's going to remember those light settings and change it for whatever you need on there. So same thing as if I was offline programming and not on my machine. The very first thing I would do is when I import the DXF is highlight all the dimensions. When I bring it to my actual machine, I'd set the light settings and right click and say set lights and zoom to that, whatever I need on my actual machine on there. And that's something that you'll learn over time if you have the offline version, that since you don't have lights on your offline version, you really can't set them to what you need specifically for that feature on there. If you want to know more about the offline version or just on your actual machine of importing DXFs, feel free to reach out to us. We can explain more about it and show you better applications on that. Just for fun tip, you can position the schematic window to zoom in or out or isometric view so your Micro-Vu report matches what you want to show. So if you want to show the more isometric view in your report, whatever we change our schematic window here to, when I go to File, Reporting, and I go to Show Displayed Schematic, it'll show whatever I have in the schematic window there. So once you finish your program, set your schematic window how you want to display on that report, and it shows a nice 3D view. Or if you're using a fixture with multiple parts, it'll show everything. If you're using this to send off to your customer or whatever it might be on there. So in the example that I had on my PowerPoint, this one, I wanted to show all 4 pieces on my fixture that I was measuring. But this piece over here, if I was just reporting sample 2 or whatever it might be, I just wanted to zoom in on that certain sample. Or if you see that out of all these parts that I'm measuring, this is the only one that's failing, I'd want to zoom in on that and maybe bring it to my machine operator or whatever it might be and show them what is more zoomed in, what's failing on there. So let's talk about position and concentricity. The newest standard, concentricity, is off, and I'll explain why. So a lot of you are still going to have concentricity on your blueprints, just from old prints and stuff like that. Don't go running to engineering and say all concentricity needs to be switched to true position. It's almost easier to measure concentricity than true position, but more and more you'll see that concentricity should be going away. Same thing as symmetry. Symmetry is pretty rare. We have a couple customers that we measure symmetry on our Mitutoyo CMM and our Aberling CMM. Micro-Vu doesn't support symmetry, but let's talk about position and concentricity. So when measuring true position, you'll see, if you're unfamiliar with it, you'll see the true position symbol here. You got this little circle with the crosshairs in it, and it'll tell you what the true position tolerance is if it has a material condition on it. So this one has max material condition, so we get a little bonus tolerance on it. And then it'll say what datum it's in relation to on here. So this true position of this thread actually is in relation to datum B, which is this diameter here. And we get max material condition on the true position, and then we also get bonus material on datum B. So the larger or smaller that datum B is influences how much extra tolerance we get on there. Few things that to keep in mind when you're looking at a blueprint and you got true position is your system needs to reflect your datums on the print. So if I was measuring this feature, this part here, I would want to make sure that my origin of X and Y is datum B. So it'd be a diameter that I'd set my origin of X and Y to. I would set my origin of Z to datum A, which is this bottom plane here. And a little trick is, I'm going to actually show you stored features. If you put this sample here onto a fixture, I'll show you in a little bit that we can measure the plane of the fixture that this datum A is sitting on. We can store that feature, and then we can place the part on the fixture, and every time that we run the part, it's not going to physically have to measure the fixture that datum A is sitting on. So it's kind of nice that if this is blocking datum A, since it's sitting on datum A, we can recall that feature every single time. And since this is a round part and datum C is this diameter here, I really have nothing to skew to reflect on my true position, since it's just the basic dimensions are going to be 0, 0, but I'd probably skew between two of these diameters just to clock my part. So since this true position is only referring to datum B, I look around my print because I need two basic dimensions, and I don't find any basic dimensions from datum B to the center of this. Most of the time on prints, since it's supposed to be center to center and they're supposed to be the same center, so 0, 0, whoever designed the part's not going to put basic dimensions 0, 0 to the center of this two features for a basic dimension like, let me find a, there's not a basic dimension on here, but just, you know, you'll see it in a box. Oh, we got a basic dimension on these angles here. So you'll see that rectangle box around a basic dimension. So I've gotten a few phone calls that they show me prints and they're like, I'm looking for the two basic dimensions, but because concentricity is off the new standard, and concentricity really doesn't tell you anything if you find concentricity out. It doesn't tell you in which direction the diameter's out on it. So true position is nice because you need to report your X and Y location, and then whoever's making the part can know how to fix their machine, whatever's making it, or fix the mold, whatever it might be. So as concentricity, you see that the center line of one cylinder or diameter needs to be 0, 0 with the other diameter on there, and you get some guard band here. So this is just a little drawing here that you're looking at good concentricity because this center circle is 0, 0'd with the outside. And if this was out, so if this is how the part was actually made, concentricity is going to be way out, and we can see that it's off center. But if we just reported concentricity being out and not reporting the X and Y basics of it, nobody knows how to fix or how much to adjust the tool to bring it back to center. So even if you still have concentricity on your blueprint, do yourself a favor and report the X and Y location of that diameter. So if something comes up and concentricity is out, you can be the helping hand to the shop floor or engineering of what needs to be adjusted on the tool and how to bring that diameter back to center on there. If you're dealing with a lot of GD&T, before I go to the next slide, if you're dealing with a lot of GD&T and you want to hear more or learn more about it, feel free to contact us. Or if you're in the Indiana area, we will be hosting that GD&T class, and I'll be bringing that GD&T class to other cities around the Midwest soon. Features and tools you might not be using daily. Some of these I don't use daily, and sometimes I forget about them. Like I said, a lot of them might not be mind-blowing, but they might be useful for you in certain situations, or just to know to keep them in your toolbox when you're programming. The first one I want to talk about is auto-generate drive points. It can make your programs faster. So basically what that does is, if you remember back to the beginning, or the beginner tip and trick that I had, was that the camera window, how wide the camera window is. So if you can fit multiple tools in your camera window, auto-generate drive points is going to take in a snapshot for as many tools as it can fit in there. So when we run this program, you guys might notice, come down here, I'll measure this. Down to my last point. This is a semi-automated program because I didn't insert the recall refsys. And now when the program runs, you'll notice that it takes an individual snapshot for every single tool that we have in our features list. And the program is not that long, but if we come to Tools, Auto-Generate Drive Points, and I click All Features, it took 27 snapshots around that part to measure the whole thing. Activating Auto-Generate Drive Points, it brings the new snapshots down to 16. So we're actually saving 39.5% of the runtime. I'm going to click Finish there. I'm going to right-click Insert, and I'm going to click Insert Recall Refsys. Highlight down to my next system, set system to my new recall refsys. Now it's fully automated. And now you can see that it's not taking as many snapshots around there because it was able to fit multiple of those tools in the same camera window on there. So we're running 40% faster. And now if you have, you know, this is only, let's say, almost 20 features that it's measuring. If you're measuring 100 features on your part, do yourself a favor and go and click Auto-Generate Drive Points and see what time you can save. Sometimes you can save a lot of time. Sometimes it's not that much because the tools you're using can't fit a lot of tools in the same camera window. But one thing to know that if you go to run your program and the camera thinks it can fit multiple tools in the camera window, but then the tools are just too large for the camera window and they fail to measure, you can go to individual features and right click and go clear drive point. So now it'll clear that drive point and not try to fit all those tools in the same camera window. So it's worth trying, letting the program run. If something fails to measure, either adjust the tool or clear that drive point. And even if you save 25% instead of 40% of your runtime, you're still saving a lot of time on there. Another thing that you might not be using every day is your points view. So we've come in here a bunch of times on our webinars. I'll open up the large view. Might have gone in a different window here. Or it doesn't want to open on here, probably because I'm on WebEx, but we'll talk about it down over here. So the points view, we can exaggerate where the points are. So I use an F-scan line down here in the points view. And when I exaggerate it, you see all the points that the F-scan circle is measuring around that diameter. And when I hover over it, if you guys look at the camera window, you can see a white crosshair, and it's showing you physically where that point is. But this is helpful if your diameter is out and your machine operators need to adjust the tool to maybe it's oval shaped, maybe it's egg shaped, maybe you know, it's just completely out of form on there. You can right click and you can save the points view as a JPEG and email it to them or bring it over to their computer, whatever it might be, and show them how the true shape of that diameter is going. You can also show max and min tags. So if you want to check for flash or maybe any chunks that are taken out of your part, it can show you the worst case scenario, internal and X of the diameter. This works for lines. We didn't use an F-scan here, but we can see if we use the F-scan, it would show us where our points might be out of straightness on there. So a lot of research and development things here. And a lot of times you might not even look at it because if all parts are running great, you don't have to, you know, determine what's going on with the part, but it's super helpful when parts are out of tolerance to see what the true shape of that diameter is actually looking like on there. I wanted to talk about camera separation. So you're able to actually pop this camera window out of the Inspect software and be able to put it on another monitor. One thing I want to say is this doesn't make your field of view, your camera window, any larger of what it can see. So we're still back to that 11 millimeters that it can physically view on there. But sometimes it is helpful to have a larger window of it open on another monitor. So if we go to Machine and we come down to, actually it's in Tools, and you go to Separate Camera Window. You'll need to restart it. So I'm going to click OK. I'm going to cancel out of that. And then I'm going to come find my Inspect software again. Now when I open it up, now my camera window is separated from the rest of the screen. So now I can move this over and make it larger. I can move this up to another monitor. But like I said, this does not expand what your camera can see. So just know that and hear me on that one. But it's nice that it's actually larger so you can put it on another monitor on there. And same thing if we wanted to get it back into the same window, we just click that. It'll require me to restart. So I'll cancel out. This Inspect loads. There we go. Now it's back in there for us to use in there. Stored functions. So let's go ahead and find if we came over, say we had a fixture that we wanted to have a sample. So if we have this sample here, let me find it. It's a little clip for automotive. If we had to measure this part, but the way that it sits in the fixture and datum A is actually underneath down here where it's sitting on the fixture, we could take the part out, measure the plane, store the feature, then put the part back in the fixture and recall that plane. So every single time we run the program, it'll remember that plane that we measured on that fixture and not have to measure it because the part's in the way. And then you're able to save time on there. Stored features, you also can store fixture systems. So if you have a fixture that you want to store the corner of it for some reason, or if there's a car position on there that you want to store that and not physically measure it. So there's tons of different options on there. And if this piques your interest, sparks your interest on things that you are having to measure and then put the part on the fixture to speed up your process, I've said it a million times today, feel free to contact us. We're here for support and making your inspection process quicker and more efficient. Well, let's go ahead and just measure the feature as my camera is trying to focus in on that. So that's a good little thing there. I didn't have a lot of contrast in that window going on, so I was having a little hard time focusing. I'm going to zoom in and get my surface back in focus. So I'm going to go ahead and measure a plane. I'm going to do more inputs because especially if it's a datum, I want to do more than the 3 inputs needed. We're going to move over to my metal part because it's not liking this lighting on the white, and I don't want to run out of time on this guy here. So I got a metal sample over here. Go. A little better contrast here. Again, I said it earlier, if you're having trouble with clear or white parts, I have that webinar that's talking about lighting, and we talked a lot about clear and difficult colors to measure on there. So if I go and measure this plane, switch to axial light on this. See if we get a better focus on the axial light. It's always when I'm live that the camera doesn't want to work on here. All right, let's go ahead and pick a different feature. It's not liking that. That's going to be something that I get to troubleshoot after I get off this webinar. We're going to do a circle here. So this is the same thing as any other feature. If we measured a plane and wanted to store it, I want to show you guys how to store features. So if we set this as our system, for whatever reason, I can right click it and I can store this. And I want to store this as datum B, and I want to save it permanently. And I click OK. So now I can put my part on the fixture if this was a plane. And when I come down to recall, we have our reference system that makes it fully automated, and that's using the machine 00. Somebody on this machine must have saved fixture 23, datum A, but also I want to recall that guy. So it's not going to physically have to measure that diameter every single time or that plane on that one on there. If you need to delete stored features, say you're not doing that job anymore, or this recall list is getting very, very long. Our Excel, our Micro-Vu Excel in the lab probably has about 20 recalled ones on fixtures that we're not going to see anymore. So we could probably go into, if we go to Tools, Stored Features, I can delete ones out of there. Because of time, I want to jump to fixturing ideas so we don't go another month without seeing those. And come down, skip back down to my fixturing ideas. So there's a bunch of different fixturing components that we use. We design and build these pocket fixtures here at ATI. You can get these pockets in any size that you guys need for your parts. A lot of times customers will go with whatever the largest size that covers the most parts, because we're able to place samples in the corner of every single one, write one program in the corner and translate it across. Also, if you have smaller parts, you can put one in each corner, and then you're able to get more out of the same fixture on there. So this is good if you don't need to use the touch probe at all, because nothing's holding down the part. We have also done where we tap a hole next to the pocket and put a nice little fixturing standoff with a clamp on there to hold the part, so we're able to use the touch probe. We do custom fixtures as well. So if you send us a CAD model and your size of your machine, we're able to custom build and design a fixture that fits your parts specifically for fully automated. And we're also able to deliver a program to you. So you don't have to do anything. Your operators just have to hit run. Here's another example of some parts, but for all of you that run multiple part numbers, you need flexible fixturing on here. So we have this threaded plate. It's kind of in a grid system that we're able to use just little screws and bolts to be able to create easy fixturing, be able to put a part up so it's going to be in the same spot every single time. Again, you can translate across the grid pattern. And this is nice too, because I know that each one of these is 1/2 inch, that when I translate, I know how far each part is across from each other. And you're able to, on a grid plate like this that would fit in Excel, you're able to fit many different part numbers on there. And if you save what letter and number those holes are in, it's easy to use one plate for multiple different part numbers. Same thing with the threaded plate, is you could put standoffs that hold a part up. So this is on one of our CMMs that we're using. So using different standoffs and different clamps, getting creative with what holds your part the best so it's repeatable and you can run fully automated programs. These fixturing kits are available for many different companies, like Renishaw, which I'm sure a lot of you are familiar with. A lot of the kits come with a lot of things you might not use. If you want some help of creating your own custom fixturing kit, again, feel free to reach out to us and we can help you with that to fit your parts. I like this guy. one of my coworkers, Zachary, figured this out for turn parts. So you can put different cones on this guy, on this side, and you have the spring load. So we're able to fit different size parts on this, and then you can put this in your stage square. So it's fully automated, adjustable length on different turn parts or plastic parts that can fit on that type of thing. And it's just really nice to be able to have an adjustable fixture that fits many parts on there. Keep it simple. We were measuring a part here. It was just going to be one part. We were actually reverse engineering this part, and we just put a little metal bar on there to hold it in the position, and we were able to use it. We measure it once and we were good. So if it's just a quick measurement, keep it simple. Last thing I want to talk about before we get to Q&A is pattern recognition. I'll show this really quick as we're running out of time here. And if you need to get back to work, I fully understand, but I'll show you here. And right after I do this, we'll get to Q&A. So if you guys have any questions, you can start popping them into the chat right now. And if I'm able to show live, I'll get to it. If it's something a little more complicated than showing live, I will take down your name. Dan will take down your name, and we'll contact you afterwards. So if I make this a fully automated program, I can use on generation 3 only, I can use this pattern recognition tool that it actually sets scans this area and places all these points around the edges of this. So then when I go to run the program, it goes and it widens that search area and it searches for those specific features that I told it to scan for. So you see it here scanning around in the area until it places and finds that shape, that pattern that it's going to recognize and be able to run my program. This is fantastic for that fixturing that I had here, that if these parts might move a little bit because it's not a perfect fixture, the pattern recognition on the Gen 3 can at least locate the part even if it's off slightly on your fixture and then run the program. So it helps with, you know, translating programs that parts aren't going to exactly fit on the stage every single time, but it's a cool little feature on there. And probably more and more webinars, I'm going to start showing off a little bit about the Gen 3 machines and what they can do and the new things in the software on there. So not to take up any more of your time, running a little long on this one. Feel free to pop your questions in the chat box if you have any. And as you guys are doing that, if you have any questions, again, remember we have a metrology training seminar coming up in July in Warsaw, Indiana, covering hand gauge, blueprint, Micro-Vu inspect software, and Micro-Vu GD&T capabilities. You can choose one day, you can choose all 4 days, whatever it might be. Contact me for more information or go to atiquality.com/events and you can register for more information there as well. So thank you for joining me on this Wednesday, and I'll be sending out a follow-up email if you would like the recording of this webinar and any other past webinars that I've mentioned today. Thank you guys for joining. If there's any questions, I'll go ahead and answer them. I'll stick on for 5-10 minutes if you got anything. So thank you all, and we will see you on the next webinar.